Hello everybody, Dirk here. Welcome once again to the Dungeon Laboratory. So, went ahead and finished up this plasma globe circuit so far. There are some things that I want to do and change. I have kind of just sitting down right now. This transformer and possibly this bridge rectifier I want to change. But I have to see if I could do something to limit the current. This is just a simple little 555 oscillator to run this little transformer that I have here, and it only has a variation here for the frequency. I think maybe if I had an additional one to control maybe the duty cycle, I might be able to get around how much this consumes as power wise. Because it's relatively low voltage, but obviously it's going to be high current. That's, basically Ohm's law there. So I can't really get around it because it takes, or it consumes about 3 to 4 amps, depending on frequency range. I'd have to measure it again. I forgot to do that. I'm going to say within, the resonant range of this transformer, which is about 30 odd kilohertz. Actually, even higher. It's probably close to 40 for this tiny little guy. I would say it's about 3 amps. Hence why I have this big chunky heat sink in there, and I'd rather not have that in order or have to use this huge bridge rectifier that's in there, because that's like I think like 800 volt 40 or 50 amp rated bridge rectifier, which is super overkill for this. But I just didn't have the components sufficient enough to, for a good power supply. And this transformer here might also be a bit overkill, and it's being kind of wasted. This is a 6 and 12 volt transformer, and I'm only using one of the taps here because I played around with the circuit a little bit, to get the best power output that I could. Within respect, because basically this is for driving or powering up a plasma globe like this. But obviously, other people don't have things like that, and they're gonna want to power it off other things. You can use neon bulbs. You can use standard bulbs, which I have here as well. It kind of depends. You kind of have to play around with your different light bulbs. This is a 100-watt one, for example. I do have a 40-watt. I think it's a 40-watt one. I'll grab it really quick. Look at it, if I can read it right. Yeah, 40-watt. And this one, I think it has to do with the wattage range and what kind of gases they're filled with. Or if there's more gas actually evacuated from the bulb. I'm not 100% sure, but this is pitiful compared to this. They're the same size, but this is 100, this is 40 watt. This does nothing, whereas this does something. But that also depends on what your output voltage is, what the current is. And for my setup, I don't want a whole lot of output. I want it tiny. Basically the same type I would get from that USB powered one I showed in my last video. And I also I'll put a link into bigclive's video of him explaining it, because he can explain it a lot better, like how these are actually produced and whatnot. He can go into more of the theory of it, and you can possibly even build the circuit that he describes in the video. You don't have to go with a 555. You can do whatever. You might even do what the magnetist had mentioned, the TL494. I think that's what it is. It's basically like an inverter IC, to pulse on some MOSFETs. Might actually be better because it has the frequency and the duty cycle kind of built into there, so you can actually limit the power consumption. You don't want a whole lot of power consumption. You want to have these small and practical. This is not ideally small and practical, but it does the job. It's pretty good for what I had laying around, and everything fits in there. Transformer. The heatsink being the biggest ones, obviously. You get your tiny little circuit board here, your tiny little transformer. You can use like a normal flyback or whatever, but smaller is preferred. And the other components, fairly large smoothing capacitor down here. It's 2200 UF microfarad, and your bridge rectifier. And then this is for the the variable frequency, because you can play around with different things, because when you're messing around with different bulbs or gas filled tubes, this one obviously works very well because that's its intended design. These aren't necessarily. This one works a bit better because it's filled with neon, so obviously it's going to react a lot better. But you're not going to get like a really flicker effect here. It's just going to be on. Because screwing this into normal mains voltage, it's a flicker bulb. That's what it is. It flickers, because of the varying frequency. And this doesn't really do that much, at least not that I noticed. I was trying to look for some normal candle bulbs, but I couldn't find any. I guess we don't have any more in the house because we retrofitted everything with LEDs, so we don't really have those anymore. So. Yeah, I was trying to do that. You could use other gas filled tubes. This is a little xenon flash tube, and I do want to go on something else. I was talking with the guys on the weekend as we do, and Sparky had mentioned the skin effect, or we got around to something like that, and there might be a debate. On the internet, probably the smaller majority, meaning that, saying that there is no such thing as a skin effect, where the larger majority says there is such a thing as skin effect. It's true. I can obviously touching this with your bare finger is a no-go. It's going to give you an RF burn. It's going to hurt. It's not recommended. But much like a Tesla coil, because this, a Tesla coil is in a sense a high frequency transformer. This is as well. This is running at like 40 kilohertz. Obviously, the lower in frequency, there is some schmegma on my my little pointer, whatever. Lower in frequency, more of the voltage is going to travel through you and not over you. Hence the skin effect. More of that voltage is going to travel over the skin as opposed to through the skin. That's one of the reasons why people build Tesla coil primaries, spark gap coils primarily, with copper tubing and not solid wire, because most of that voltage is going to flow on the outer portion of the copper and not through the inner. So that's just a waste of copper. Obviously it's easier to bend copper tubing as opposed to solid copper wire. But that's the main gist of it, and people that say there is no such thing as a skin effect, I'm sorry, that's a load of crap, because we got this plugged in, right? Yeah, we can just turn this on. You're not going to hear anything. Obviously, you can't see that very well because I have that bright light in the back. Turn that off. Turn this off. Turn this back on. Alright, this is going to a xenon bulb, and we'll do just a little poker. So, yeah. I didn't feel a thing. Didn't hurt me. I'm perfectly fine. Going into regards to that, obviously there's certain conditions that would arise where that wouldn't be such a good idea. If you have neurological conditions, heart conditions, pacemaker, that sort of thing, that wouldn't be a very ideal thing to do, drawing arcs from a high-frequency transformer of any kind. But in the long run, it's fine. I wouldn't even advise doing that, like long term. It could be that the the radio frequency, because not all the voltage passes over the skin. You know, some of it does pass through. It's probably going to be very minimal depending on the frequency range, but it could damage, you know, possibly damage the nerve endings, you know, kill them off, and probably over a period of time you're going to start losing your feeling in your fingertips and whatnot, or they're going to be tingly all the time or whatnot. I don't know. I'm not a doctor. I don't know any of that type of deal. It's just my opinion, what I think. But yeah, not to go into that in greater detail. This is basically the project here that we're talking about. So we'll go ahead and put that in there. I kind of set that up to where that sits inside there pretty snug. And, you know, we can turn the lights back off again. And you have your little variations, you know. Obviously this is for mainly built for the plasma globe, but then you have a larger bayonet for your standard bulbs, and the smaller one here for smaller bulbs, such as that. Or I even had the unfortunately this doesn't work for some reason, probably too low in wattage. It doesn't have enough gas evacuated out of it or whatnot. This little pygmy bulb doesn't work. It's dead anyway. But yeah, turn it on. There you go. And that's perfect. And that's kind of what you want to go for. I watched a lot of YouTube videos last couple of days on plasma globes and, you know, designs and whatnot. And this is perfectly fine. This is kind of what you want, because a lot of the times I can even smell it now. I can smell the ozone on my fingers, which is okay. I can even see a little bit. I can really feel it, you know. I don't know if that's true with the normal plasma globe that I have, the normal plasma circuit that I have. I'd have to look into that. Yeah, but you can definitely smell it. So hey, you know, if you want to clean your hands, get them germ free because of the coronavirus, just, you know, build one of these and just stick your hand on top of it for just a few seconds, and then wash your hands off, obviously, because of all the corona gas. But it smells oh so fresh and nice. Yeah. So, you know, you have that. I'm trying to do this one-handed, so hopefully this kind of works. Might be kind of a long video here. There are other things I want to do. I'll probably get back to this project because I do want to modulate this as well, possibly with music or some type of low-frequency oscillator, something to not necessarily interrupt it. Interrupting it is different from modulating it, because you're going to use the pin 5 control voltage input from the 555 to modulate the signal already that's going to the MOSFET. Let me turn this on again. And that works as well. It's not really great, but you have to say I had to lower the frequency a little bit in order for it to do that. And that's more in the you know, resonance of where it's supposed to be. So that's what that is. We can take this bulb out. It's kind of a tight fit. It's an older connector there. I'm probably referring to it the wrong way. I know it's a bulb holder. I'd say bayonet connector, because that's in the UK they have bayonet style bulbs that are a bit different. So then you have your little tube there. It does flicker a little bit. Not so much. It does flicker. And that's me just adjusting the frequency. So yeah, all in all, it's quite a nice little circuit to play with. Like I said, it's not perfect. It's not the ideal circuit. Probably the ones that are actually in the plasma globes themselves, at least the ones that I saw. There's simple ones, more complicated ones. Just smelling the ozone on my hand. It's kind of nice. My fingers are a bit tingly now from all that. Yeah, there's a lot of different circuits in order to do this, but this is a simple one that you can set up. Just checking the. It gets warm, but I can probably run that, for quite a while, and it would run quite happily. That is, I was going to use that other transistor, but the output wasn't very good. Because it was just a lot of playing around and experimenting, to power the circuit and to have enough power to give to the high frequency transformer here in order for everything to run properly the way it should. So I went ahead and just stuck with the IRFP 260N, which I believe, yeah. And that's like a 20 amp MOSFET, so that should be able to run like that for quite a while. But obviously, if I was going to put in that other additional control circuitry, which is probably just a couple more components to vary the duty cycle, I think it's the dead time or whatnot. Maybe it wouldn't consume so much current, which would be nice. 3 to 4 amps is a little overkill for something like this. Obviously, that little USB one that I showed doesn't consume near as much. I mean, your USB outlet from your laptop, for example, might give like maybe an amp max. So I'd rather have something like that. It's something I have to play with. Yeah. So there's my little project. Well, hope you guys enjoyed. Stay safe. Have fun. Cheers.